So we're going to talk about where's my money gone. So if we're building a stable system, a strong system, as Mrs. May would say, what are we going to need to actually make that happen? So a bit of intro about me. So Chris Burrell, head up the tech at Landbay, been there 2.5 years, something like that. The business has been running 4 years. And before that, worked for HMRC, worked for EE3, a few of the big kind of telcos there. We'll talk a little bit about Landbay, just to give you a little bit of context on where I'm coming from. And we'll look at, I've kind of selected really two processes that I think underpin robustness, two architecture principles that we might want to look at, and two implementation concerns that are kind of at the coding level and design. So a few things that we're definitely not going to talk about today, apart from this one slide. We're not going to talk about backups. We're assuming people take backups or point-in-time recovery, that kind of stuff. Geographical resilience, so having multiple availability zones, different regions, ensuring that your system kind of behaves if your cloud provider disappears. We're not going to talk about ACID relational databases. We'll mention the database themselves, but we're taking for granted that people know that a relational database is atomic, consistent, isolated, and durable, right? So we rely on those external tools, and we're not going to talk in detail how that's managed. And obviously, a big thing in financial systems is security and fraud. That's not the topic of this talk, but what we will be talking about is the kind of principles that we've used to actually develop software on those platforms. And so to start with here, just a little bit about Landbay. If you like, it's a peer-to-peer, but rather than files, it's money. So you guys have £100, maybe £50, £1,000. You give it to Landbay. We find someone who needs a mortgage. And if there's enough of you, we can give one mortgage out. So when they pay their interest, you get the interest. We take a small cut. So banks, if you've got an investment account with them, maybe you're getting 0.5%, maybe 1% if you're lucky. In peer-to-peer, you'll get anything from 2-3% up to 11-20%, depending on your risk appetite. So we're particularly in the kind of mortgage business. So if your investment, if your borrower doesn't pay, you've got a property behind it. And so you can sell the property and get your money back. So it's a safer type of investment than, say, investing in someone's kitchen, because there's no kind of recourse there. But essentially a marketplace, investors like you and me, and maybe institutions, and borrowers who need a mortgage in the buy-to-let space. So our tech stack, quite small, as it says, startup, 4 years. So we've got one test environment, one production environment, one DevOps environment. And that's kind of how we've split stuff. And we'll come back to a little bit of that when we look at quality. Why is it so small? There's some reasons around that. And we use a number of AWS services, so the authentication stuff in IAM, KMS for encrypting data. We use all the ECS orchestration for our Docker images, and so on and so forth. So there's a few here. So here's I'm not sure you can see it from the back, but if you start from the bottom up, so you've got your user, access is a load balancer, so there's your kind of typical kind of 3 or 4 tier architecture. So you've got your web servers, and we've divided that public and private with various firewall rules and different instances. Your microservice layer, so that's where we'll run all our codes. Our code is Java code, and we'll run Spring Boot apps. We've got a few Node apps on there as well. So agnostic of technology, but everything in Docker. Then we'll run a data layer, so where we've got some persistent data, so RabbitMQ, for example, runs on that layer, and if the server dies, we want to bring those servers back up with the same storage. And then there's stuff around the side and at the top. That's all the kind of managed services that we use with AWS. So an RDS database, master-slave. They don't, apart from Aurora, they don't provide a kind of master-master configuration. A bit of Elastic Cache, so Redis for session management and caching throughout our app. And a number of other things, so RDS, CloudWatch, some other tools there. So in total, at the moment, that's looking at about 40 microservices. As a startup, we've had the opportunity to start from the ground up, so there's no kind of legacy code as such yet. I suspect with microservices, we've already replaced one, so you could kind of say there's been some legacy code. All of our infrastructure is provided by Terraform, so we've scripted all our infrastructure as code. And finally, we kind of script our pipelines as well. So there's no manual coding or clicking in Jenkins. Everything is in a script file in Bitbucket. And then we store that pipeline with our microservice and then Jenkins also detects how to deploy stuff. So the plan. So we'll look at two key processes first. So let's look a little bit about how we do QA, and I've called it CDEP. I think it's quite confusing sometimes if you say CD. Some people mean continuous delivery, some people mean continuous deployment, and so we mean continuous deployment at Landbay, and for us that means several releases a day. Takes about 6 to 8 minutes to get code into live, and therefore accuracy for a financial system, it becomes quite important. So some of the guys in my team, they've worked previously in advertising or media publishing. I think everyone wants quality, right? So it's not we're doing it better, it's just where's the focus. So in advertising, if something goes wrong, you don't get an advert, I think the user that's probably quite pleased. In Landbay, if they lose their money, it gets a bit emotional. Similar in media publishing, maybe it's accuracy of the content or uptime that you're so much interested in. For Landbay, really it's much more on the data quality, managing the data between services and making sure you don't lose some of the data along the way. So if you're going to lose some money, obviously the customer's going to take his savings out and disappear, but we need to report a penny break. So if our bank says a penny more, a penny less, we need to tell the Financial Conduct Authority. And presumably, if that happens a lot, then they'll remove our license. If they remove a license, that's it. That's the end of Landbay as we know it. 4 years in business and then bust. So that's something, obviously, we don't want to happen. And also, from a kind of slightly more specific type, the money obviously gets emotive. Like, you've probably been on a call with customer services somewhere, and they don't really quite understand what the question is, and you're kind of saying, no, but the site says this, and it's not this, and it gets quite emotive when people's money is at stake, as opposed to, say, reading an article or something like that. People kind of care about it because you've kind of worked hard to earn that money. We've got a reasonably large transactional data set, so it's not big data type stuff, but we allow people to invest a single penny in a loan of, say, 200,000, right? So the way we model that data ends up being quite granular, so we need to kind of have quite a bit of audit around that. And then finally, there's quite a lot of interacting use cases. So say you're an investor and you register, you put £1,000 on the platform, it may go into a new loan that's coming along, and then you'll get the interest for that loan. But someone might be withdrawing, and so there's a secondary market, so you buy his loan off. So in terms of testing, it's there's quite a few cases like that in our business, where there's lots of interacting use cases, and on top of that, those use cases are lots of different microservices. And so the question really is, what are the challenges, particularly, say, for end-to-end testing? So we do all the kind of industry standard stuff of coding, unit testing, code reviews, and we've got something called service testing rather than end-to-end testing. So what I mean by end-to-end testing is probably what you know as like Selenium type testing or testing on a UAT environment or a pre-prod environment. At Landbay, we started doing that. We had about 1,000 Selenium tests, and then actually we said, no, this isn't working for us. It's not stable. It's not fast. It really causes issues with microservices in particular. So I've got a few issues up there. So you're going to set up your data, but actually you really only want to test a feature. Maybe that's 1 or 2 services. Why test the entire thing? Well, you could argue consistency, but from a logical perspective, if you haven't changed stuff all over there, there's very limited reasons why you should test stuff kind of that. You test your services here, but you don't really want to spend a huge amount of time there. In particular, with microservices, say I'm building a feature and it serves ABC, but someone else is building a feature and they are also changing service A, but it's DNE, and so on. We've got a large team, say, so not large, but say 6 people, and they're all on their kind of different features. It becomes a bit tricky in terms of managing releases. So suddenly I need ABC, but that guy needs DNE, and then how do I orchestrate it all? Is it a manual thing? Do developers kind of have to remember which services go first? Do you have a kind of a service equals a feature, but actually in practice they've all got contracts, so how do you manage contract compatibility? So what we've said is actually let's get back to the kind of microservice paradigm, which is you want microservices to be independent. So you've got independent pipelines. Now, if you're saying independent pipelines, waiting for all your services to land on an environment before you can release, actually that isn't an independent way of doing things, right? So if you've got 2-3 services coming in, and you need to wait for those, but then there's another story and they want to deploy that as well, then you kind of lose that independence very, very quickly. So rather than doing that, we've shifted left, so we push all of our testing slightly further, and we test each microservice. So we'll do 2 things. One, test the service as a kind of black box type testing, similar to how you would have end-to-end testing, but in this case, a slightly smaller unit. And then we'll test contracts between different services. So does this REST contract over here still match, or is it still backwards compatible with what's live? So those kind of things are things we test. So some of that stuff we can do at compile time. Some of that stuff we'll do at build time. In particular, that has a change in focus in terms of how developers approach code. So you've now got more accountability on the developer. So there's no end-to-end testing. That means no QA team as a kind of a separate unit. So all of our software engineers are now accountable for the code. So I don't know if you guys have been in an environment where developers develop, they think they've met all the acceptance criteria, bang, over the fence, and then testers get to do it. They usually get very little information about the contract that you've implemented. Maybe they get very little information about how the internals work. So rather than doing that, our accountability is firmly placed in the hands of our engineers. And obviously that makes them more engaged in the business, because you need to know the business if you're going to have a good view of what testing you need to do. And finally, obviously it changes the recruitment to your candidates, right? So the first question we ask is, what do you know about Landbay? And if there's no research, that is the end of the interview. And we've often said we're happy to re-interview, but actually there's no real point in kind of continuing if there's no investment in the business. And so I tried to map out roughly from my previous experience where people spend most of the testing, or most of their effort. So you probably can't see the labels there. So the first column is kind of the build and unit tests. Obviously you want to spend most of your time there, right? So that's the more time you spend there, the more value you have in the business. You're building lots of stuff. Typically, integration testing of services or interfaces, that hasn't had a huge amount of focus. But then everyone kind of latches onto Selenium. This is great. It's kind of starting loads of Chrome browsers and Firefox and Selenium Grid. I can run stuff on 6, 8 servers, and then you kind of start thinking about, are they repeatable? And a lot of people run tests 3 times and get the best of that. But typically, you end up either, and my experience is either people say, no, we're going live, and your testers are like, well hang on, we haven't actually started, or we're kind of squeezed out because the development's taken so long. Or you do that commitment and you have a lot of tests. And so we did have a lot of tests and found it extremely difficult to get those interacting use cases out to set up an environment right. And so typically if you're in a kind of CI environment, maybe continuous delivery, your kind of deployment to UAT might be daily, maybe it's every night, maybe it's every sprint, a couple of weeks. And as we saw in some of the other talks, the kind of deployments to prod used to be expensive with CI, and that's kind of getting closer and closer. Maybe it's months, maybe it's quarters. So as I hinted earlier, what we do is we do the whole thing in 6 minutes. So obviously not the coding bit. It takes a little bit longer to code. So you're doing all your code. You write all the tests as part of the code. So you kind of code, unit test, and the testing of the services. But then when the developer presses the merge button, that's it. It's gone. And you can monitor it, and it takes 6 to 8 minutes through there. So obviously, what does that mean in terms of quality? Well, that means that we've got other processes in place in terms of code reviews. We've got a kind of checklist, and we're not looking for style. We're looking for accuracy. It also means in design, we get several developers usually designing a particular story together and making sure that from an architectural point of view, from other people working on the code base point of view, and just from an enterprise type point of view, everything kind of fits together. So we place a lot more emphasis kind of up front in terms of quality. So again, that kind of shift left pattern. Also, if you're going to shift left, there's more testing on the left-hand side, which is great, but there's slightly more risk because obviously you're not testing the environment as it holds together. And so in this case, we shift right. So we've got the people here like App Dynamics, APM. We're using a tool called Dynatrace. And so a similar concept, you can get lots of data very quickly. And I think one of the benefits, obviously, of this is if you need to roll back, having a fast pipeline means you can do that very quickly. So often the question is, well, hang on, we're used to doing lots of testing. And I think this is I think if you Google kind of testing and microservices, there's very, very few blogs around that. Maybe a few more this year, but certainly last year when I looked at it, there's very little. I think you do need to kind of remember, why are we doing unit tests? Why are we doing testing as a whole? Ultimately, it comes down to kind of money versus service, right? Whether that's the service level qualities, the SLAs, the service level agreements, the experience of our users. Ultimately, the question is, where do you want to spend money, rather than should we spend the money? Everyone wants to kind of get high quality. Does integration tests for microservices really add the value that you want? Well, we kind of thought, no, let's bring them forward and invest in a solution afterwards. So hence the monitoring and the web checks there. So obviously, some of those benefits are up there. So smaller deployments, we'll know, because every feature goes in individually, we know straight away, right, which one causes a break, and we get alerted very quickly. We've got monitoring in place. The monitoring will log on to our system production, carry out some actions, and so we'll know that through the synthetic testing that something's wrong. But ultimately, as with every other business, we don't really want to rely on that, hence all of the testing up front on the left. Obviously, the other pros, faster delivery for the business. So if you were in the continuous experimentation talk earlier, then that's kind of there, and so on. So here's our pipeline, what it looks like. So build, service testing, where we check all the contracts, then build the Docker image, store it in a Docker registry, deploy to UAT, deploy to prod. And very occasionally, and we've probably done that 3-4 times a year for a feature, something's actually quite big or quite risky, or maybe it needs a little bit of orchestration, and so we've kind of got a manual approval type flow which will chop the deployment and actually wait for someone. So for example, we could, if we wanted, deploy everything to UAT and then do stuff. But we do need to remember, when we're doing that basically the entire release pipeline for the company or for those particular services is kind of blocked, because once things are in master, you kind of are committed to either rolling that back or moving forward. So the next kind of process that we look at, especially from a financial point of view, is reconciliation. I think the first two are kind of obvious, and most people in finance systems will look at that. So your business, obviously your platform that's tracking money for different people, needs to match the bank, and so there's ops and some tech involvement there. Third parties, so maybe you're relying on third parties to provide reporting to HMRC or whatever it is, so obviously you'll reconcile the data there. We'll focus more on the kind of tech side of reconciliation and across multiple services. And so you've got 20 services now, and then your data is kind of spread throughout, but you need it to be consistent. But we've just said microservices need to kind of be independent, right? So what we've done is set a specific URL for every endpoint, and if it wants every service, and if it wants to expose some data points, then it can. Yeah, so it's totally optional, but it can just expose points. So every new service, bang, you can just have class, expose 4 data points. They can be metrics, they can be, say, numbers of accounts, they can be lists of account numbers or IDs, whatever you like. And then we've built a reconciliation service, and the idea of the reconciliation service is to run some rules. So a very simple rule is every user in our environment has got at least one account, right? So if they register, they get a classic account, they can open a nicer account if they want. We've got lots of rules like that. So if your data is split between services because you've kind of got a feature-driven type design, you might have bits of a loan over here and bits of a loan over there, and you want to make sure you've got the same number of loans. So we've got quite a number of those, and we've built a little dashboard. So here we've got the kind of rules. We nicked all the images from Jenkins to kind of have nice sunshines and history. And then the data points there on the right, you can see no attention to UI and UX and stuff. This is purely for technical people. But that runs every 2 hours, I think, at the moment. Probably runs every hour next year, something like that. But the idea there is to get a fairly quick feedback loop in terms of if something's not quite gone right. So if someone's broken a key use case where this rule doesn't match anymore, then we'll know straight away. And so we'll get a Slack message from that. We'll be able to check this board. We'll be able to see the history of when the rule broke and how often it is. And that we'll also have in that same support portal, we've got the git commits of all the commits and the latest commit of every service. So we can kind of check that particular rule is associated with these services. I can see what the commits are and therefore what's the latest deployment that's gone. So second, we'll look at some architecture principles. And two in particular, I mean, there's quite a few. I didn't want to rehash the kind of common microservice principles of service discovery and configuration and the kind of 12-step stuff. But in this case, I just want to pick two. So we're in the cloud, and you usually would do microservices in the cloud, though I've heard of people who haven't, which is also good. But why not use the cloud more as a platform rather than infrastructure as code? Certainly my journey has been infrastructure first, and then actually I could use this bit, but do I want to tie myself to the cloud? I think it's quite common in my experience that people don't use cloud because they think they might move, say, from AWS to Azure. In practice, I'm yet to come across someone who has done that, who's actually moved from one cloud to another. Similarly, if you're using something like Hibernate, a lot of people say we like Hibernate because we want to move from one database to another. I think, it's not as trivial as that anyway. But actually, does that happen in practice? It's quite a big commitment for a company to say, I'm just going to ditch MariaDB or MySQL and go Oracle. That's quite a big shift for a company to make. So in this case, I just want to take an example where we've got an SFTP server with that durability. And so obviously, you can guess we're using S3 for that. So we're not achieving that. AWS is achieving that for us. Whether we need that in practice or not, we might be able to cut off a few lines, but it's good to have those if we can. But obviously, this kind of offload requirements to cloud provider kind of applies to things like using RDS rather than hosting your own database. So that's the kind of idea here. So in this case, we use Packer. So Packer is a tool to generate your Amazon images. And so this is the kind of Packer script, very, very short, 15 lines. And then possibly you can see that near the back, but maybe not. But it will run a script on an instance before images instance. In this case, we install all of the packages. S3 Fuse is a way of mapping S3 to a file system. So then we've mounted the file system on the box. And then there's a couple of lines chopped off there which just map it into FSTab. So basically, we're configuring a Linux box which already has SSH, which basically is SFTP, right? So SSH over FTP over SSH. And then we've mapped that to S3. If the box dies, we've got that image, it starts up instantly. We've still got all the files because they're on S3. So this is kind of just an easy way of kind of thinking, right, do I need to buy an SFTP server? Or maybe you do because you've got requirements around kind of moving files atomically and stuff like that. But maybe you don't. Maybe there's some stuff out there, like if you want to build a new call center, AWS have got a call center off the like out of the box. So there's just various things like that that's actually worth considering when you're in the cloud. So obviously with this, we don't need to worry about our data. We don't need to patch S3 because AWS do that for us. The SLAs are kind of taken care of, and security is kind of all integrated to cloud system as well. Other stuff, and some of these are kind of more traditional, but I'll just pick out a couple from this slide. So obviously we've got logging, monitoring, and our attitude to microservices is to keep them small because otherwise they're not micro. But under logging, I think we get the browser logs as well as all the application logs. So the browser will be sending back any error, and that will be that will have request correlation IDs, session correlation IDs, so that we can tie it to all of the sessions that the user's done. So every log statement that we have has got those IDs, and so if we go to our ELK stack, Elasticsearch, Logstash, and Kibana, then we can see it, but we can see it from a browser's perspective as well. So are they having a good experience? And the second thing here is around the kind of dynatrace, and we mentioned that a little bit before, but I just want to cover that a little bit in a second. And the final thing, something that I've learned actually, we first started to go down a kind of domain-first approach for cutting microservices up. So we drew up our kind of initial data model. We said, okay, loans, that sounds like an entity, and investments, that sounds like another entity, and accounts. That's great, but what we found actually is that a feature doesn't really work on a domain. So it usually works across multiple domains. So a user might log in but have some money, and so you're kind of starting to access multiple things. So as one thing we've learned as we've gone forward actually is that the feature, the microservice more represents a feature than a particular domain. So for example, if we've got something to diversify people across multiple lanes, that will then collect its data from other services, do stuff, and then do an output, similar to kind of a function. And so by doing that, we found you kind of make the services smaller and smaller, which is good if you need to replace them or if you need to isolate bugs. But it does cause issues if you've got lots of services. So here's our Dynatrace dashboard, similar to kind of App Dynamics. And so here's an example of something you can get. So obviously you've got a request to Tomcat, and it says localhost because the container thinks it's localhost. And then in this case, you can see it goes agent service to kind of do some authentication, a call to the database. There's a few things with RabbitMQ in the middle, and eventually you can't quite see it there, but it kind of goes into our reporting data warehouse. So suddenly, whether it's HTTP or async messages through RabbitMQ, your monitoring tool can capture that and can visualize something. So that's quite useful for things that are a little bit more complicated. And again, you possibly can't see that from the back, but that particular message listener, which is receiving a message from RabbitMQ, you see straight away it's making 74 calls to the database, sounds a bit high, and it's making 24 calls out to RabbitMQ to send messages. So suddenly, without having a huge amount of knowledge about the system in order to troubleshoot the performance, you can get quite quickly to that. So we haven't had to code anything here except install an agent. And that's kind of one of the powerful things about the tool. But ultimately, I think that the lesson is if you want to troubleshoot 40 services, 60 services, 80 services, you really do want to have kind of tools that match the scale of the architecture. So finally, we're just going to briefly talk about some kind of more design coding kind of things and how we've kind of looked at data resilience. So got a pile of services here, and they're growing all the time. What happens if you lose a bit of data? That's not necessarily a kind of a catastrophe type scenario, but there's a bug that's been in the system or something unexpected happened. It's never happened for the last 2 years, but it suddenly happens. You've got a bit of data corruption. I think that probably happens to everyone. You do your best to catch it, but what if it does happen? So I think I kind of looked at the architecture a few weeks ago and said, right, so here are some of the patterns that I think we've put in place without necessarily realizing, but actually crystallizing it makes our design now a little bit easier. How are we going to reconstruct the data if we lose it or if we lack it? So as part of our coding, as part of the design phase of this, we'll be kind of looking, do we need to store the data at all? Or how do we work with it? How do we recover it if we need to? So one thing we've got is kind of double-sided accounting. So you've got, say, two services. We've got an account service and a loan service that manages your investments in loans. If you're moving money from what we say from one service to another, then we will capture the fact it's left here and arrived here. So that sounds noddy, but ultimately that means that if you lose some of the data over here, you can use your service on the right to recreate that, right? So and we do that pretty much everywhere that we move money around. So there's no time that we move money where we don't have at least two representations of that money. The other one is cause and effect. So things are asynchronous, for example, or you do something, it causes something else. Generally speaking, we, for example, don't do many updates to our data. Our data is mostly immutable. We create new rows for everything. So a balance for us, we don't actually store. It's just the sum of all your transactions from the beginning of history. But sometimes you'll need to update data. And what if you need to kind of recover the point just beforehand? So generally, you'll have traceability, whether it's in logs. Logs aren't great to parse, especially when it comes to financial data. And so what we'll have is tables that effectively act like a log statement. But for example, we will allocate, you've got £1,000 going in, and it goes in patches of £10, 50 quid, 100 quid. We've got rows in the database for all of that in one service, which then means we could recreate the kind of final how much is outstanding in another. So it's a kind of subtly different thing to double-sided accounting. It doesn't quite match, so it's not quite as good. But you can still kind of look at that data and come back to it. Do normalizing. So often for performance, you might need to bring in bits of data from two different places, bring it into one place, and kind of have a kind of slightly longer view denormalize view of the data. Again, obviously, if you've got denormalized data, it seems quite obvious that you can put it back to where it came from. You might not have data completeness with this, and it might be slightly harder to manage in terms of data updates and mastering of data, but at least it's kind of there. And then the other thing that we've done is we've got an audit service that captures lots of business audit points, but also captures every single event in the entire system, albeit with a slightly restricted kind of payload, but we capture every event that happens. And so when it comes from troubleshooting point of view, you can use a lot of that data to work out what's happening in the system. Reporting, again, we do something very similar this time. So audit was an Elasticsearch, reporting is in a kind of Redshift type database. And again, we capture every single event ever sent, both because it's important for MI, but also it's quite a nice source of data for troubleshooting a platform. And finally, obviously, we've got logs, but they don't tend to be so useful for recreating data if we ever need to. And so obviously some challenges with that I've put there at the bottom are you need to kind of work out who's mastering the data. So it's kind of if you've got a conflict of data, you obviously want to know who's correct. And one distinction that we've made is to say there's some data we actually really care about, and there's some data actually we don't care so much about. So there's your cash balance is obviously something we do care about. But the fact that you logged in for MI, for audit, it's useful. But if we miss one or two because there's an outage or because there's a bug or something like that isn't going to kill the world, right? So we've kind of told the business, if you want operational data and you want operational reporting to HMRC or to kind of legislation type things, you use that kind of hard data. But if you want to do intelligence type analysis, business stuff, or product improvements, then you can use the hard stuff, but you can also have a whole load of richer stuff, operationally, richer stuff, which we all call soft data, but it may not be 100% accurate. So you might see that you've got 100 logins instead of 99 or 101 or something like that. So we're now going to talk a little bit about resiliency, consistency, and transactional boundaries. So old systems, maybe you're using something like WebLogic or a container that provides really strong transaction management, provides your queues themselves. And then within your queues, you've kind of got your transactions and you've got XA and two-phase commit so that you know everything's consistent all the time. Not so easy with microservices. You can do a little bit of distribution and use kind of external transaction managers, but it comes at a cost. And so ideally what you want is your messages in your database to always be in sync, right? So you don't really want to fire a message and roll back the database because then you're kind of causing issues in the rest of your platform. So I've just got a few conventions for some of the slides coming up. So a service is in blue. If it fails, got a little red box around it. Transaction in blue. If it fails, again, it's red. HTTP, straight line, and a message, kind of asynchronous dotted line. So the easiest example here is to have a portal. Maybe it does an update to one service, so that service has got transaction boundaries. If something goes wrong, then obviously you report to the user, but that transaction rolls back. The portal doesn't have a database, therefore you're kind of okay. That's quite easy, right? But if you've got two services, you're doing a little update to your cache. Great, excellent. I've done that. Then it goes to investment, but suddenly your server dies, or there's a bug, or whatever it is, that transaction rolls back. Obviously now you've got a little problem, because you've updated your cash balance. Maybe you've taken money out, but you haven't actually put it into investment, because that transaction will roll back. So in this case, obviously, that just doesn't work. And so you need to kind of either manually roll back your cash balance thing. Not ideal, because that means you have to start thinking about every single failure in the entire system. And every developer needs to do that for every story. So as I mentioned, one of the things you can do is use a distributed transaction manager. And in this case, basically, you start the transaction at the front and at the back. And so your transaction happens within. And then if it fails, the entire thing rolls back. Now, if you think of that from a performance point of view, if you've got one user, great. If you've got 1,000 users, you're managing lots of open transactions on lots of services. And so that particular thing that's managing that transaction really needs to be highly performing. So not easy to set up and quite performance consuming. There's a couple of blogs that I've put there, quite useful. They say they've solved the problem, or at least they're solving the problem. That wasn't in place when we started. So really two software patterns that we've got, and then I'll explain the kind of nitty-gritty in a minute. One is to kind of chain stuff. So obviously here, I'm sending the message within the transaction boundary. So if something rolls back, the message doesn't get sent. If something fails in cache, investment never knows about it. If investment fails, then the investment transaction rolls back. Not great, but not disaster, because we've still got that message, and that message will live on a dead queue. So the investment service gets the message, but never acknowledges it with the queue service, and therefore it goes back onto the queue, can be retried. We've got a retry policy of 3-4 times. Eventually, if it doesn't manage, then a support engineer comes in and does something. And the other example, obviously, is preferred. So just one note on this. When you use chained events, obviously with 2 services it's quite easy, but if you think of 20 services all lined up like that, it becomes a bit tricky to work out what's going on where, right? So ideally, if you can afford to do that, we kind of use the asynchronous approach full on, but that comes at a cost for the user. So user's done something, but then if everything's asynchronous, maybe your page refresh is a little bit faster than it takes to carry out your operation, at which point he's confused. I'm just withdrawing 100 quid, but it's still saying I've got the 100 quid there. So it's kind of a trade-off really between a user interaction and everything being asynchronous, and therefore that's a little bit easy to manage because you know up front there's the entry point, and the entry point for withdrawal cache is there, and then you can trace the message from there rather than having to go from one service to another. So the question is really, how do you manage getting a message rolled back at the same time as your database? So things like RabbitMQ, for example, and Kafka when we're using it. So Kafka didn't support transactions at all. RabbitMQ doesn't support 2-phase commits. So the stages would be that. So you start your messaging transaction, start the DB transaction, you do some stuff, you send some messages, you commit your message, and then you acknowledge you've received that first message if it was triggered there. That's great, but there are 2 issues there. One, after you've committed, there's a small chance that your system might go down, and then after you've committed your messages, you might not have acknowledged stuff. So that comes at a trade-off. Usually that only happens within the context of your infrastructure failing. And so what Spring does, its attitude is to say, actually, the time between the DB commit and the commit to the queue, I'm going to shrink as quickly as possible so that there's not absolutely, but there's as little chance as possible for that to happen. That's great, but there are some issues with that. If you're running clusters, less of an issue because you've kind of got a bit of redundancy there. But again, can you send a message over here and commit it over there? Some queue systems allow it, some don't. So rather than that, instead of that, you could do something like this. And so we do that in some use cases and not in others. So in this case, you start your transaction, slightly optional there. Again, do your DB transaction, but rather than sending messages directly, you can store those in an event store. Maybe it's a database, maybe it's a load called Kafka with a persistent disk or something, but it's in the store. And ideally, it's committed at the same time as the database. In this case, you'd commit your database, and then you've got an asynchronous process running in the background, which just reads those messages off. So if your database fails, actually your messages, if you're storing them in the database, they're not there because they got rolled back. That obviously comes a bit of a performance cost because the messages aren't sent straight away to the queue. So there's a couple of articles there if you want to delve into a bit more of one phase commit and 2-phase commits. And I'll make the slides available.